Okay, so let's look at distribution. Let's apply it to some real world situations, or at least kind of real world. And so you have some scenarios here. There are 6 scenarios on your note sheets here. So looking at the first one here, and again, we might have time to talk about all of these. It'd be something good to maybe contact me or office hours to discuss why are these distributions, if you have questions about them. But just looking at a few of them here, number of miles run by Saturday morning joggers at a park. So think about how many, now distribution, right? We're looking at a distribution. So what are all the possible values for that variable? So think about a jogger. Each jogger will run a certain amount of miles. That's variable. So the number of miles is a variable. The distribution of that variable will be what are the potential values. And so I just put 0 to 10. It could be maybe 20, but I'm just thinking of at a park. And then the other part of distribution is how frequent, how often would we have that? And so the distribution I decided to draw was skewed right, meaning that there'll be a lot more people from the 0 to 2 or 3 miles and only a few people at the high end, like 10 miles. And so that would produce a skewed right distribution. Again, distribution is important in statistics because it's a way we describe the data. It tells a story, right? There's a story. If the distributions were different, then there's a different story to be told. Like the second one, number of hours spent watching football on Thanksgiving Day. Well, if you're a big football fan, football's on all day, up to 12 hours a day. So you'll have a big group of people on this side, a lot, right? Remember, because this is frequency, right, along the vertical axis. And number of hours is the values of the variable. And then you have a lot of people who don't watch any football, and so you'll have a high end right there also. And so that's why you end up with a bimodal distribution there. And so looking at these other ones, you'll see these distributions are, in my opinion, based off my real world experiences, thinking about why these variables would have these distributions. So I want you to consider that, right? So take a look at those 2 lottery winnings, rent of a 2-bedroom apartment in Santa Ana. Continue to think about distribution as the amount, right? We also named the shape. Remember, that's where these shapes came from, these names from here. And so my thought were they would have these distributions. This one was a random. Last digit of phone numbers would be 0 to 9, the last digit of a phone number. And so it should just be randomly or uniformly distributed, right? Doesn't matter. It could be any number from 0 to 9. And so forth. So think about that there. Let's continue on with some more examples here. Here's an actual histogram here. I kind of approximated them with my shapes, my curves, right? I didn't draw on the full histogram. Here is a histogram. And to describe the distribution, we're looking for shape, center, and spread. That's the overall look here. And so I see a symmetric shape here. The center is somewhere in the middle here, and these were prices of avocado. I was curious about why avocados cost so much in some places. I looked up the data, and this was from 2018. The average price per avocado across the country for hundreds or almost thousands of different retailers. And so you can see the center is about $1 to $1.20, which would be the average, and the spread goes from 40 cents all the way to $1.60. And so that's the beginning of us discussing distribution, the shape of it, and the center and spread. Here's another distribution. The number of characters used from 50 emails is given below. So emails are short, so there's not a lot of characters. And so you can see a distribution skewed right? Most of them are in the short end. Center, it's hard to find the center in this case. We'll learn how to do that. It's going to be closer to this side over here, but we'll learn how to calculate that. Right now I have a question mark for that. And the spread goes from 0 to 60, as you can take a look at that there. That would be our spread. Again, we're going to talk more about that. And then we talk about these kind of terms over here. These are called outliers, potentially, like really far from the rest of everyone else.